We want to talk about I/O in Java specifically, and just as a process, we've used this with Java a little bit already. We also use it with C++. But today we're going to look more specifically at how we can use input in a couple different ways, as well as writing to a file, and look at what it takes to actually use that inside our project. And so we're going to be putting together some stuff with us. We want to take a look really quick about how we're going to do that. And so with Java, we have our hard drive. And our hard drive to Java is just, here's this spot that we can save information to. And we want to find a path that we can have access to. And when we're working with this, we have access by default to certain parts of our path. And so what we have is what is called our class path. And it's what Java can actually see inside our thing. And we're using Eclipse, and so we have access to a couple different spots. We can access the entire hard drive in Java if we choose to. There's a couple different ways we can do that. We can actually specify an absolute path, which is the directory of how we get from the root level of the system for // on a Windows box to / on a Linux/Unix/Mac OS box. So we have a whole bunch of ways we can actually see that. But what we're working off with specifically, making sure that we're working with me as well. What we're working with this is we're going to talk to our part of the project where we're seeing ourselves, where our project itself is running. That's what we're going to be talking to. And so we're going to be working within that today and how we're going to see that. And so we have our project right here. And so in our chatbot folder, we have our source folder. And inside the source folder, we have our package, which, chat dot, which are, of course, just folders themselves. So we actually see what's inside that. And that's what we've been working with. And so we're going to work with a couple different ways to do this. So we're going to use, to make this, we have a Java class called file. And the file class is part of java.io. And the java.io is the library in Java that allows us to get access to all the components we need to do input-output operations. And a file represents, in computer land, just any structure we can use. And really a file can be either a directory or it can be an actual, item. When we think of a file, we usually just think of a file itself, like something we can like myname.txt or word.doc or whatever we're looking at for docx or whatever we're seeing. But in the computer land, a file is actually a directory or an item. They can be either one. And so we have to actually look at how we're going to work with that. And so we can actually ask the file, are you a directory? Or are you not a directory? How big are you? How much space is available right now that I can use? How much space is inside this file? These are things we can ask a file. And obviously, if it's a directory, it doesn't have a size. Because a directory is just a little folder that we can put things inside. But a file has size, we can actually ask it that stuff. And we'll take a look at how we can see information about that later. But we have these two different ways of looking at files. So we have to ask, is this file a directory? Or is this file an actual file item, something that's stored inside a directory? And the directory we're going to look with is inside our chatbot project. We're going to work with a couple different parts. We're going to look at the actual root level of the folder right here, aka at chatbot itself. That's where we're going to be working with by default. But we can also go inside, and we can, like we've been doing when we're loading images, we go to our chat folder, and inside the chat folder, we go to our model folder, and we're going to put a data folder in it. And in that data folder, we will have commonwords.txt. And so we can go in that. We'll also have it loaded right here inside our root folder of the project and just have common words right here. So we can actually have our folder open in two different ways, so we can see how we can open in two different styles as we work through this. And so we can use the file like this to open right here, to open directly from right here, or we can go path inside, opening with a resource like we've been using already to open images to put our GUI components inside our screen. So the way we're going to work with right here, opening it from directly right inside the file, is we're going to use the magic power of the scanner. Now, we've used scanner already to read keyboard input, passing it keyboard.system.in. And that's how, if we make a scanner passing it system.in as the parameter, it can open up, and we can read from the keyboard, so we type at it, and it captures the keyboard input. But a scanner has multiple things it can actually read from. A scanner can also read from a string. And so you can use scanner to parse out a string and actually get all the individual parts of the string and read each piece, one piece at a time. So you can do all those manipulations we did with reading from the keyboard, like grabbing the next int, the next double, all that stuff. You can do that inside a scanner as well, off of a string. The other thing that we have for a scanner, and the one we're going to be using this time, is a file can be a parameter. And the file parameter for a scanner what that grabs is it's saying, I'm going to open up this file on your machine. And by default, when you're opening a file inside that, it goes to the root level of that project where we see inside the class path of this. In this case, it's the project folder. And so it's going to open up here, and for us, it's going to open up commonwords.txt. And so when you pass a file to the scanner as a parameter, it opens it up right there. But wait, there's more. We can also open up an input stream. And if you notice, all these are capitalized, lovely little things. These are all different things that are inside Java we can use. So sys.in is for keyboard input. String is so we can parse out a string using a scanner and it's all of its methods. A file is how we open files. We can read a file that's text. Now this is only text files. We can't read image files with a scanner. Sorry, there's not the text we want to read inside them. But we can also open up an input stream. So we actually open up a stream of information. And a stream is a more advanced way of actually handling the text. And you can do some really cool stuff with it, because you can get a stream, like say, for example, from a website. You can get a stream as it's pumping stuff out continuously. There's lots of ways to getting that. And in fact, when we're using C++, we're talking console out. That's the output stream we're talking to. And so we can actually use all sorts of cool stuff with that. And so Scanner can take all these as parameters, and it can work with them and parse the text out of them. And so we've already used it with this in class for keyboard. And we've talked about using it with a string, and that's just obviously opening a string parameter. Today we're going to be using it with a file and with an input stream. There's two different ways of actually handling it. Now, when we handle the scanner and a file object, because we can't guarantee access to that, that means we have to make sure that we handle that lack of access guarantee using the standard approach of a try catch. Let's take a look at that over here. So with a try, we have our block of code, we have a catch, and in the catch block we have some exception. And I generally give it the name error because error is an easy name to remember. And when we're handling this with Scanner, what we're specifically working with is we're going to be working with an IO exception. And that IO exception, what it does is it's going to say, oh, you can't handle this. There's something that's not available, like you don't have file permissions. You can't read from that part of the hard drive. That file doesn't exist. Oh, you're trying to read a file that's you don't have permission to read, because in Unix and Linux / Mac OS, you can give permissions that only certain times of people can open files using the chmod operation. In Windows land, as long as if you can see the folder, you have access to the files, and so we could actually open up basically anything. But we have right here, we can set permissions. Your user doesn't have permission for that, and so we have that handled with an IO exception. And again, we've built that error handling method into our controller so we can display that information to the user, because the user doesn't want our program to crash, and we don't want our program to crash either. So what we do is we're going to use the ability to handle those errors and have just little pop-up messages to say, hey, here's the error, deal with it on your own, we're moving on. And so we have that with our app controller .handle errors. And we pass it error. And so we have that lovely line right here, so we can handle the errors right that with app controller.handle errors, where app controller happens to be the name of our app control, our controller object we're running throughout our project. It could be called app, it could be called anything, but that's just what we're using to actually mark what we're actually handling it, because the controller, again, remember, is what we use to actually pass information back and forth, because its job is to send information from one part of the program to another, so that each program handles the things that it knows how to do. Now, this exception, of course, can only be thrown if we're doing something inside this try block that's going to throw an exception. You can only catch something if it's thrown to you. So, unlike Lucy with the football and Charlie Brown, where she's holding the ball out and he runs up to catch, she pulls it away. It's like, yeah, he'll never kick it. But with an exception, the only thing you can do is you can only catch exceptions if they can be thrown, and not every method can throw an exception. Only things that have the possibility of causing an error can throw exceptions. And so what we're going to do is we're going to say we're going to create a file in here. And we're going to say file equals new file. And file, one of the parameters it can take for its constructor is a string. And some string parameter will go inside here, and that's going to create the file we're going to use. And that's going to say, oh, open this file. Okay? And that itself doesn't necessarily cause a problem. Because you can say, oh, here, open this file, and if it doesn't exist, like, okay, sweet, there's no file there, no big deal. But then when we try and actually access the file, we do that with the scanner itself. So this could actually happen early on, but we want to actually put this all together because it makes sense to block it off in code. The next step we have is we're going to, after we create that file, is we make a scanner object. And so scanner, file scanner. And again, we use really boring file names or variable names because that way anyone who's reading our code can get an idea of what's actually happening. We're not trying to obfuscate our code. We want our code to be understandable to ourselves later on, but also we want to make sure our code is understandable when someone else who's not a programmer can look at it and they can say, oh, that's what you're working on? I can actually understand what you did when you're putting this together. Because by doing this, not only are you helping yourself later on when you're like, what was I doing when I worked on this project 6 months ago? But you can say, oh, you can give this to your boss, and like they can actually see what you're doing, because sometimes you actually have to explain to a non-computer scientist, to a non-programmer, what is this code supposed to do? And by giving actual words that make sense, you have a better chance of having that happen. And so scanner file scanner is a file, and we'll then just initialize it, equals new, of course, because everything in Java gets that new keyword. And it's going to be a scanner, of course. And we'll pass it as a parameter. We're going to pass it a parameter to that file. And so file my data. There we go. Give it a nice little name. And we'll pass it my data. And at this point, here's where it would throw the exception if it's not able to get into it. So it's like, oh, you can't scan that thing. It's not there. So, that's why it's inside that try catch. So if it didn't work, it's going to crash and break. But instead of crashing and breaking, we have it handled with our method that we've already built inside our controller to handle those errors. So our next step that we're going to do is we need to then loop over that file. Now, because we are using a file, we don't know exactly how many words are in this file. We don't know how this file is stored. Now, I have made the file so it's all line by line, which makes life a lot prettier, and you can easily read through things because it makes it easy. But we don't know exactly how big it is. And so in order to figure out how big this file is, we're going to use the loop that it ends when we don't know how long it's going to execute. And what loop is that when we don't know how long it's going to execute? We want to do something we don't know how long it's going to take. We have to do it over and over. What do we use? What loop? We don't know how many times, but we know we have to do it until it's done. A while loop. Fantastic. Now, where were we again? Oh yeah, what kind of loop do we use when we don't know how long something's going to take? So we have Simon says, clap your hands. Okay, it's a while loop. Everybody, Simon, clap your hands. Simon says stop. That again is an example of a while loop because we don't know when to stop. We repeat this until we're told to stop. The for loop, Simon says clap your hands 5 times. Okay, with the terminable loop, where we say do something a certain number of times, it's like, oh, execute this time, this time, this time, this time. So a while loop, again, is what we use when we don't know how long something's going to happen. We want to do this until it's done. And so that's what a while loop is for. And so we're going to use a while loop to iterate over our file until we're done with the file. And then when we're done, we do want to make sure that when we're done with the loop, we have some while loop in here. So while and some condition. And we have our squigs. And after we're done with the while loop, we need to make sure that we close the scanner. Now, most likely, we're not going to corrupt our data. Java is pretty nice about releasing things when it sets things null because the garbage collection is built inside it. But in other operating systems and other tools and other things, you have a great chance of causing actual damage to your data file if you don't close the stream that's talking to it. And so it's really good practice, especially when you're doing things like networks and sockets for security purposes, when leaving a security socket, a network socket open so you can talk to some port on your computer on the internet. You leave that port open and, open port. Data. We don't want to leave that open. We don't want to let someone just like, hey, we can just keep grabbing data off of our running program. That would be bad. And so it's really important that after we're done with the scanner, we close the scanner. So the very last thing before we hit the end of the catch block, and we go into that, is we do the file scanner dot close. And so that's what we have to make sure we set up for that. And we have that basic process. So we have a while loop right here. It's going to loop in some condition. And what we have inside a while loop, we've used this with scanner before. Scanner has a method inside it that can say, is there something left? And that method is hasNext, or hasNextLine. And we're going to specifically use the hasNextLine because we're grabbing lines of text one at a time. And so while file scanner dot hasNextLine. And so as long as there's a line inside there, it's going to keep reading into this. And so it has that process that's going to read through this over and over again. And that way it can grab that information, read from the file over and over and over. When it no longer has a next line, we close our squiggle. We then close our scanner itself because we want to have good, secure programming practice. There's not really a big chance of it being hurt, especially with a Java app running where it's not going to cause actually corruption of data or leaking data. But especially when we get into more advanced programming, this becomes very important. We close those out. We hopefully don't have a catch happening. We don't throw an exception. So this hopefully does not execute. And then once we're done with this, we'll continue on with whatever method we're doing so we can actually go through and grab that. And so this is the process we are going to use to actually go through and read through the file. And so let's go ahead and let's go take a look back here at the code, and let's go and develop this.